Hi, I'm Colby Eskew, and this is the group's final project, milestone 4. And so, what I'm going to be doing is breaking down our low fidelity prototypes and kind of showing you how our design has evolved over the past semester. Okay, so our initial idea was pretty much just to have something that kind of fixes some of the problems that we commonly had while we were using the terminal. And so our first idea that we really had was a cheat sheet that was integrated into the terminal. And so you can see some of the designs that we have gone through so far. So I'll point out in the first one. Our initial cheat sheet idea was just to have the cheat sheet be a button in the top right corner of the terminal. And then we kind of just developed from that and sprung a couple other ideas. And in the background, you can just kind of see some of the different variations we've had so far. Soth will talk a little bit later about the higher fidelity mockups, so let's go ahead and move on to our second kind of main idea that we had and made some lower fidelity mockups for, and that would be the error resolution part of our solution. These designs, much like the cheat sheet designs, are all based off, or mostly based off of clicking a button or typing a command into the terminal. And it's just a couple of different renditions which we went through trying to figure out which looked the best or just kind of had the best feel to it. And finally, for the third aspect of our solution, we centered it around 3 user stories. One that bases it off of having a button, much like the other two. Second, which would require the students to install a plugin, which could be used to help them out by giving them hints. And then finally would just be a user installed file on Odin that could be used to show hints.
So the first high fidelity mockup that we created was based on the user story of having an easy access cheat sheet for the user. So we decided on having a help button up in the top right so that when the student clicks the help button, they'll have a drop down menu filled with options for helping, or like help sheets. And so when you click the coding sheet, you would open up a new window on the bottom where if you click the coding cheat sheet option on the bottom, it would switch you to a new tab. And so if you wanted to go back to the home window, you could go back and forth having a cheat sheet on the bottom of your tab. Similar to this idea, we created another idea with common errors. So we had a common errors tab so that when you clicked common errors, it would open up a common errors tab in the bottom so that you can switch back and forth from the home window and the common errors tab to help the student. Our third high fidelity mockup was based on the instructor asking the students to install a plugin at the very beginning of the semester so that when the students clicked hints or typed in hints in the command line, it would automatically open up an Emacs frame containing the instructor content for that given module. And so using all 3 of these high fidelity mockups, we compiled them into 2 high fidelity prototypes. And so based on the third mockup that I showed you, we discussed installing a user program. So the user would install this library, CS1302 hints. And so once they installed it, they would complete it and it would tell them type in hints into the command line to open up content. So when the user typed in hints, it would give them a Emacs page containing the instructor content. So that was the first high fidelity prototype that we created. The second high fidelity prototype that we created was based on the first and second high fidelity mockups. And so we decided on having a help button up in the top right, which would create a drop down menu with a cheat sheet and common errors buttons. And so a cheat sheet, content, and common errors buttons. So when you clicked on content, it would drop down a menu on the right side of it containing the instructor content, which would also have an exit button so you can exit and use the terminal as it should. And so when you click cheat sheet, it would open up a cheat sheet with common Unix line commands so that if a student was ever stuck trying to navigate through the terminal, they could open up this cheat sheet and they'll have a whole list of commands to help them out. And then thirdly was the common errors. And so when you clicked common errors, it would open up a common errors tab. and it would help you with syntax errors, runtime errors, checked errors, and other hints. And you can always exit it out. And then if you wanted to close this drop-down menu, you could click exit, and it'll go back to just a simple help button up in the corner so that it wasn't too distracting and wouldn't take up too much screen time. And so these two were our two high-fidelity mock-ups, or high-fidelity prototypes that we created to kind of combine all of the user stories that we came up with earlier in the earlier milestones to help the students navigate the terminal better and understand or learn more from the terminal, as it is kind of hard for the students to get past that learning curve. And so this was our idea. These were our ideas for the our final milestone.
Our research question is, does the new design of Terminal help introductory computer science students at UGA complete homework assignments and projects more efficiently? We will conduct an experiment within the classroom combined with surveys given to professors and students to test this research question. We have chosen Seaside 1302 as a class to conduct this experiment, and for a few reasons. The consistency of the class across professors, the minimal number of professors, the amount of time spent in terminals greater than most, if not all, introductory classes at UGA. These decisions have been made to reduce confounding of inconsistency in class content and methodologies of teaching from different professors. Experiment will be conducted as follows. The professor will be aware of the experiment. First half of the semester, students will go about their course using the normal plain terminal as all recent classes prior half. Professors will teach the first half of the class normally. After the halfway point, we will encourage students and professors to complete a voluntary survey. The survey for the student will ask how often they went to office hours, ask a question publicly on Piazza, ask a question privately on Piazza, how often they looked up navigational commands, looked up Emacs commands, looked up compilation or running commands, how often they looked up methods using APIs, and how long on average do they spend per week on homework and assignments. And lastly, what percentage of questions that you asked in office hours or on Piazza were conceptual questions. The survey for the professors will be what percentage of questions that you received in office hours or privately on Piazza were conceptual questions, and what percentage of questions that you received in office hours or privately on Piazza were related to either navigational, Emacs, or compilation or running commands. At this point in time, we will update Odin, which is UGA's main server for computer science students and professors, for all Seaside 1302 students with our high-fidelity prototype seen above. This design enables students to access helpful cheat sheets and commands to enhance their coding experience. We hypothesize that students will benefit greatly from having in-terminal resources readily available. Surely students will need to do some research on their own, but our main goal is to mitigate the amount of tedious hours spent looking up navigational, Emacs, and compilation commands. We chose to add the updated terminal in the second half of the semester to allow for the students to develop some research techniques, as these are essential skills as a computer scientist. The professor will continue to teach their class normally after having introduced the new look Odin to their students. At the end of the semester, we will encourage students and professors to complete a similar end-of-year survey. At the end of the year, students will receive the same questions as before, as well as questions related to the terminal. They will be asked, I preferred using the updated terminal, and they will have to choose strongly disagree, disagree neutral, agree, and strongly agree. And the other one is, I wish I had the updated terminal all semester long with the same answer choices. And then we'll provide some open-ended questions like, provide at least one feature you'd like to see added to the updated terminal, and provide at least one feature you didn't use in the updated terminal. This will allow us to see how effective and how useful the terminal actually was for these students. Similarly, we will ask the same questions as before for the professors, and we will also ask them if they would like any features added or removed. So this two-part survey will give us a lot of insight as to the effectiveness of the updated terminal. All of the responses, excluding the open-ended questions, will be given numerical values that will help us gauge the benefits or lack thereof of the updated terminal. Regarding the first group of questions, we will analyze the difference in number of questions asked and type of questions asked over the two surveys. If you notice a significant number in the total number of questions asked, we will note that as the terminal having a helpful effect on the student's experience. We will then dive into the type of question asked. We will look to see if there's a decrease in the non-conceptual questions asked as hypothesized. A significant difference here will be attributed to the updated terminal, as students are more quickly and able to access references relating to their given non-conceptual problem. Similarly to the last section, we will analyze the second group of questions, looking for a significant difference in the percentage of questions asked that were conceptual in the second semester. Again, if we find a significant increase in the number of conceptual questions asked, we will attribute that to the updated terminal. We will also be noting if there's a significant change in the average amount of time spent doing homework and assignments per week. Here we will be looking for a significant change in the average amount of work per week. This data point is mostly to provide to the professors as they may want students to be doing assignments a certain amount of time per week, and if the updated terminal is taken away from that time, they may choose to not implement that in their class the next semester. In the end of semester survey for the students, we have added 2 questions related to their preference to using the updated terminal and 2 open-ended questions regarding anything they would like to take away or add to the updated terminal. The first 2 questions will have a range from strongly disagree to strongly agree with a numerical value assigned to each response. We will compile those responses and see what the average scores to better gauge the overall response to the updated terminal. Responses to the open-ended questions will be compiled and read thoroughly to allow us to better understand what the students liked and disliked about the updated terminal more than simple numerical data points. For the professors, we will ask some percentage questions about the types of questions received in office hours or on Piazza. We will be looking for a significant difference in the number of non-conceptual questions received. This would help us draw a conclusion that the updated terminal is lessening the number of non-conceptual questions. This data point is correlated to the students' responses, but also allows us to verify the validity of the responses from the students. In the end of semester survey for professors, we will also add 2 questions about adding and removing a feature that we gave to the students. This will allow us another point of view of helpful additions or removals that would help the professors teach better and more efficiently. All of the data being collected will be in 2 anonymous voluntary surveys conducted at the middle and end of semester. This negates the necessity of informed consent. Since these surveys are anonymous, we aren't able to gauge individual growth, rather growth as a whole. We will put in place minimum time requirements that will automatically discard responses that are completed too quickly, as these can be assumed to be filled in with inaccurate data. We also acknowledge that there may be recency or original bias, but in order to not interfere with professor instruction, it was important that we provided the plain terminal for the first half of the semester for all students. There also may be some skewed responses for students that have had prior experience using terminal, but the survey is anonymous without response tracking from survey to survey, as to keep this survey anonymous and follow research guidelines. Lastly, as the semester goes on, concepts generally get more complex and students get more familiar with terminal, so there may be a skew in the responses because of this. This is part of the reason we chose to not provide the updated terminal until the second half of the semester, because some students may value the learning curve and we wouldn't want to take that fully away from them. Note that this research can be conducted safely during the pandemic because all experiments and surveys are computer related with no in-person activities necessary.
Cameron Clark here with a brief summary of what we learned. The first thing all of us learned is that making a design is a lot of work. There are multiple variables one has to consider and then reconsider. People and the technology they use are diverse, which means the design has to account for a lot of different users and devices. For our project, making an accessible design required us to understand the backgrounds of the potential users and what would be familiar to them. This is where user stories could help in the design process. Putting ourselves in the shoes of the user and going step by step through a potential use case streamlined the process. I learned to appreciate methods that incorporate user perspectives into the design process and found user stories to be the most useful tool for that purpose. We also learned that to properly communicate when designing, we have to know some vocabulary. Properly putting in words our thoughts can increase productivity, as we do not have to explain and then re-explain why something does not work or why we made a certain design choice. Being able to concisely state, there's not enough contrast between the buttons and the text is very fundamental, but allowed us to quickly fix design issues that could seem simple but hard to articulate. When designing together, we mostly used Figma. Figma was a useful tool and mostly straightforward to use, but it was useful because of what it enabled us to do. Taking what is inside of our heads and quickly giving it form through software like Figma was enjoyable. Being able to quickly make something and then show each other what a specific design would look like was handy and made the designing process more satisfying overall. And then lastly, there was what we learned about proper research. Doing research involving people has many ethical issues, some of which are not easily noticed. Having multiple perspectives that approach the research from different points can help catch these issues, but the work we did on milestone 1 did prove useful during this final milestone. Being aware of potential pitfalls beforehand was also a good way to avoid ethical issues. For example, in this last milestone, our user testing protocol underwent multiple revisions as certain methods had issues such as privacy concerns and improper informed consent. Having multiple perspectives within the group really helped with that process and showed how easy it is to make mistakes when conducting any sort of research. And the brief training we had proved useful when making these protocols. So yeah, that's what we learned over the course of the milestones.